Hi there, Turgeon here, bringing you physics from afar. This is MCAS review. This is about skills. Remember, we're trying to learn this stuff. In particular, this video starts at number 19 of the practice test. Please remember, the point is to get expert advice, so you need to listen. No closed captions. Remember that when you want to learn something, you write it. Writing over and over again, writing a little bit extra, understanding, because we're trying to think. This isn't about me giving you the answers. This is about understanding the ideas, understanding the physics concepts. But there's also some skills. This test is about logic and reading. This test is about the equation sheet, how to use it. Number 19, take a deep breath. Don't freak out. You can use some logic here, but you kind of have to use the equation, or you have to really understand the relationships here. This is about Coulomb's law. Coulomb's law says there's forces. Here's an equation. It's right there on your equation sheet. It's right there. Put the numbers in. You're going to get some decimals. Pause this, and you'll see what I did here. Put in the decimals, divide by the distance squared. You get various numbers. You can see this one's the greatest. You can see this one's the smallest. Y is the greatest, X is the smallest. Remember, it asks you to go least to greatest. Sorry about the aspect ratio on this document camera. Number 20, this is a good review of circuits. Particularly, this is Ohm's law. Again, right there on the equation sheet. You see it? Right there at the end. It even tells you what each variable is. It even gives you unit symbols for things, not necessarily every unit. So we have voltage, current, resistance. We know what the current is. It's 0.5 amps. So if you do some math, or if you just kind of look at it, you know that the resistance has to be 24. There's only one of those that has a resistance of 24 if you add them up. So choice C. 21, quick and easy. Remember the relationship between temperature and kinetic energy. But remember, it's the temperature and it's the kinetic energy, but it's the kinetic energy of molecules, not the entire object. Thermal energy is also kinetic energy of molecules. So that's clearly telling you that the answer choice is A, because that's the only one that mentions an increase. 22. We're trying to use the equation right there on the equation sheet. How are you supposed to know this? I mean, it mentions frequency, hertz. It even tells you hertz is that symbol right there. It doesn't tell you that hertz is frequency, but if you think about the difference between frequency and force, that's reminding you we have this wave equation right here. V equals lambda F. V is velocity of the wave, lambda is the wavelength, F is the frequency. Plug in the very large, yeah, that's a really large force. Write this down. Sound travels fastest through solids. So you can solve and you'll get a wavelength of 10.4. Divide both sides by 400. This time, part B, we have, oh, okay. This time, part B, we have a, this really should be labeled part C, waving people off. I'm recording a video. 400 hertz is our new frequency. Sorry, I'm trying to rush. People keep coming in. But they're simply asking for this answer choice because sound going through air will be slower. Very strange, but if you think about it, the sound has to pass through particles that are really widely spaced, so it actually ends up going slower through air. We're going to talk about light later. For part C, you can see that If we were to decrease this velocity, that means the wavelength has to decrease, and the answer choice is B. Number 23 is about two things. It's about energy, but it's also about objects that are accelerating due to gravity. So if we look at the energy situation, you can see that W has more energy when it begins because it has a greater mass, even though it's at the same height. Greater mass, same height. So whenever we say that potential energy equals kinetic energy, this is energy conservation. I would write that down. But be careful. We're saying potential energy is at a different point than the kinetic energy. So the potential energy at the top is equal to the kinetic energy at the bottom. And I put roller coaster because you're often going to see roller coaster situations where you have something moving through like a curving path. It doesn't have to be an object that was dropped. So the answer for number 23, I call this A and B. For this one, at the end, they're going to have the same kinetic, they're going to have the same something, and they're going to keep their energy. But since object W started with more potential energy, it's going to have more kinetic energy at the end. Part B, they accelerate at the same rate, free fall. All objects fall toward Earth with this. That's on your equation sheet as well. Yours might look a little bit different from this, but they're going to tell you that the acceleration is 10 meters per second squared at Earth's surface. So, and everything that pretty much happens in our lives is at Earth's surface. So they are going to have the same velocity when they hit the ground because they went through the same distance. There's another video that covers number 24. But electric field strength, these charges are kind of affecting the space around them. If you were to put another charge there, and the weakest electric field is somewhere X, Y, or Z. These are actually really similar because the strength and weakness we determine based on how packed these lines are. Here they're the most tightly packed, so that's where the field is the strongest, and that's where it's going to feel the greatest force if it's a charge. Number 25, we have an object that looks like it's moving at constant velocity. Then it looks like it's changing its velocity and increasing its velocity, which means that it's accelerating. So one thing to keep in mind is velocity. If you look at the value of the velocity, if you look at the magnitude of the velocity, that means we're talking about speed. So I think the answer choice is clear. It's going at the same speed for a while, and then it increases its speed. You can see I'm trying to not let people just kind of read the closed captioning and then throw the answers in because it's not about the answers. Remember, listen for the skills that I'm using, the logic, and like not getting overwhelmed by the reading and not freaking out by the reading. This is called interference, wave interference. When two waves interact, they kind of overlap for a moment, and there's a moment of overlap where they have a total energy that's greater, and the energy is in the amplitude, not in the wavelength. So one of these answer choices correctly takes two 5-centimeter waves and builds them up to be more than 5, and they don't cancel out. This can happen if one of them is like above the axis and one is below, like if one had a positive 5 and one had a negative 5, but it's not choice C. It's the one where they add up. This is one of the harder problems, but one thing you want to remember is conservation. Whenever you have a collision, objects sticking or bouncing off each other, you should think conservation of momentum. The total momentum before equals, and then the next line is total momentum after. Write that down somewhere. Like writing this down is good studying. So here's how I did this problem. Just get the total momentum before. Luckily, they're both positive. If this one were going the other way, that would be negative. We got 2.9. Because you take the momentum of one and the momentum of other. And again, on your equation sheet, you can see that momentum is mass times velocity. So then I know the momentum after has got to be 2.9. The total momentum after has to be 2.9. The mass is 1.7. So I'm going to plug in the mass. The mass 1.7. What are you talking about? Well, when they stick together, they become this object with a larger mass. 1.2 plus 0.5 is 1.7. So again, there's not much. That's the part that people are going to get stuck and just rewind the video and just hear those explanations again. Why is that 1.7? So you plug in 2.9, 1.7, divide both sides by 1.7, and you get, this annoys me, but you get an answer that's very similar. I don't know why they did that to you, but you get a velocity. Now you got to think, is it going left or is it going right? Well, this was going right, this was going right. The final velocity will be going to the right. That's logic, even if you didn't know the momentum. That's going to be it for now. I will make another video for the free response. This has been physics from afar.